In service alert programs, we talk a lot about using the service manual and the Tech 1. But when electrical diagnosis gets down and dirty, a technician's best friend is the Fluke 87 volt ohm meter. Hi, I'm Jim Scopolitas. Today's program will review the basic functions of the Fluke and then look at some of the more specialized functions and how useful they can be. What you'll set the dial to most often, of course, is DC volts, though you could choose DC millivolts for very small voltages, or AC volts to read direct output from sensors that produce an AC signal, like wheel speed sensors and permanent magnet vehicle speed sensors. Of course, to measure voltage in any of these voltage positions, the vehicle circuit must be activated and the meter connected in parallel with it, comparing voltage at one circuit location to voltage at another or at ground. On the other hand, with the dial set to the ohms position to read resistance, the vehicle circuit must be de-energized. The meter applies its own small voltage, so resistance in a selected part of the circuit can be measured. But measuring ohms doesn't tell you what happens in circuitry when it's under load. So a more frequent use of the ohm meter's test circuit is a simple check for an open. If the tested section of circuit is closed, if there's proper continuity, the meter will beep. That is, unless the beeper function has been toggled off using this beeper button. Another primary use of the ohm meter is checking for specific resistance in a special conductor, like a spark plug wire, or in a component, especially one containing a coil, like this injector. Then the ohm meter's test circuit is as simple as this. And the reading is around 13.1 ohms, which is within spec for this particular injector. For this kind of measurement, the leads could be connected in either direction. The ohm meter's test circuit can also be used to check the ability of a capacitor to hold a charge by pressing the blue button. Whenever that's done, the meter displays capacitance. But you won't often be checking capacitors in the shop. All the functions at the ohms position of the dial apply a small test voltage, though not enough to turn on the semiconductor junctions in a diode. But technicians do sometimes need to check diodes, like the diode that protects the AC compressor clutch circuit from voltage spikes whenever the coil is de-energized. To check that a diode like this is working, that is capable of letting current flow in one direction but not the other, the Fluke provides a diode function. With the dial in this position, the meter applies a higher voltage, enough to cause a good diode to conduct. If the diode's in a vehicle circuit, at least one end of the diode must be disconnected for this check. With the leads connected one way, you should see the voltage at which the diode begins to conduct. With the leads reversed, you should see OL for out of limits. That diode's good. If a diode's inside a component, you might get an inaccurate result by testing this way. Instead, check for a spike in the circuit, which would prove the diode had failed. We'll get to that later. Now, for all the functions so far, the Fluke's negative lead has been connected at the common jack, and the positive lead at the volts ohms diode check jack. But to measure the current flowing through a circuit, with the dial turned to the amp position, the ammeter function must be connected in series with it, and the circuit must be energized, of course. For most circuits, the positive lead would move to the amp jack. For a very small current, you'd use the milliamp microamp jack. Notice that both amp settings at the dial are for DC and AC current. You can toggle between the two by pressing the blue button. Now, For you and me, the main use of the ammeter function is checking for parasitic drain on the battery. We'll get back to that. Now, sending vehicle current through the ammeter really puts it at risk. To protect it from any excess current, both amperage circuits are fused. The amp circuit is rated for 10 amps, and the milliamp microamp circuit for 400 milliamps. Anytime you've finished using the ammeter function, don't put the meter down until you've moved the positive lead back to its usual position. All over the country, repair shops are full of meters with fuses that have been blown because someone connected the meter to a hot circuit with the lead in an amp jack. How are the fuses in your meter? Here's how to check. Set the dial to check resistance. Touch the positive probe to the terminal in the amp jack. The contacts inside are split, so be sure to move the probe around. The beep for continuity tells you that the fuse is good. You can do the same at the milliamp jack. In the various functions, the Fluke auto ranges, selecting whichever range of units is appropriate. Here, it's the 400 ohm range. Here, it's the 4 kiloohm range. But there are times when you won't want auto ranging. To select a range manually, press the range button and hold it until the word auto disappears. Then press it again to scroll through the ranges. To return to auto ranging, press and hold range. When ranges change, especially in ohms, the trick is knowing how to read what you're seeing. If you need a refresher on that, bone up on it using the reference guide. We've reviewed the meter's basic functions. Before we move on, I want to make a pitch for using voltage drop, your biggest help in many tough diagnostic situations. To understand voltage drop, remember that all a voltmeter ever does is compare electromagnetic force, or volts, at one point with electromagnetic force at another. If an activated circuit is good, with little unintended resistance, then the difference in voltage between ground and each connection on the power side should be nearly the same as the input voltage. And the difference in voltage between ground and each connection in the ground section of the circuit should be close to 0 volts. In a battery voltage circuit like this one, a difference in voltage of more than a few tenths of a volt from battery voltage on the power side or from 0 volts on the ground side indicates problematic resistance in the circuit. For example, 2 volts difference between the bulb's ground terminal and ground itself would mean too much resistance in the ground section of the circuit. You should then check voltage drop across smaller sections of the circuit until you find the excessive drop. That is, an excessive difference in voltage between the 2 probes. In this case, in many cases, the problem turns out to be a loose, dirty, or corroded ground terminal. Your reference guide shows a table of suggested specs for maximum acceptable voltage drop in a battery voltage circuit like this one. Of course, some circuits are much more sensitive than that. In 5-volt circuits that carry signals to and from electronic control modules, much smaller amounts of resistance can be disastrous. They're especially likely to occur in ground circuits. The reference guide also includes maximum voltage drop specs in ground sections of these circuits too. For more on this subject, see Service Alert 91-14, Testing Grounds, Why and How. Knowing how to use voltage drop is one of the most important skills in electrical diagnosis. Now for another function of the Fluke. We've said that you use the ammeter mainly to check for parasitic draw. And when you do that, you can get help from the meter's MinMax capability. In any of the major functions, MinMax captures the lowest and highest readings and computes the average reading over any period of time up to 36 hours. MinMax can capture readings as brief as 100 milliseconds, a tenth of a second, but to catch them, it doesn't have time to auto-range. So to use MinMax, you need to choose the function. Let's say DC volts. Press range to exit from auto-range, and press range again to scroll to the range that would include the highest voltage you might see. Let's stay in the 4-volt range. Here, we can demonstrate MinMax using the erratic voltage readings you get when the meter's not connected to any circuit. Press MinMax to start the function. The meter displays record and beeps every time a new high or low is recorded. To stop the recording, press hold. Now we can play back the results. Pressing MinMax the first time displays the maximum reading recorded, 156 millivolts. Pressing it again displays the minimum reading of minus 76 millivolts. And pressing it a third time displays the average reading of minus 2 millivolts. At this point, you can either press hold to resume MinMax recording or press MinMax to exit from MinMax. Now, let's say you're diagnosing parasitic drain of a battery. You've heard of situations where a trunk light goes on intermittently when the car is parked and the contacts get really cold. Could that be what's happening? To let the meter check for drain overnight, connect the ammeter function of the Fluke in series with the battery negative cable using the parasitic draw test switch J38758. This tool lets you wait to switch current flow through the meter till current is low enough for the meter to handle. See section 6D1 of the service manual for important details of the procedure. Set the Fluke with the dial in the amp-milliamp position and the positive lead in the amp jack. The MinMax function requires being in a manual range, so press range to exit from auto range and scroll to the 40 amp range. Then press MinMax and go home. The next morning, you can read the results. Let's assume that the typical parasitic drain for the vehicle is about 0.03 amps or 30 milliamps. If the maximum reading is much higher than that, say 870 milliamps, that's strong evidence that something turned on. This minimum reading, which is close to the normal parasitic drain, shows that the problem drain wasn't on all the time. But if the average reading is also high, you know that the extra current draw was occurring during most of the test period, explaining the battery drain. Of course, the next thing would be to narrow the list of suspect systems. Remember, never crank the engine when the meter's connected in series with the battery, and afterward, never leave the positive lead in the amp jack. Those are two great ways to blow the fuse. What else? Let's say you suspect that a voltage spike in some circuit is what's blown a component. Can MinMax catch that? Here's a coil energized by a battery. When we break the circuit, we create a spike. Now let's go after that with MinMax. DC volts, exit out of auto range, and let's choose the 400 volt range. Now, MinMax. The meter's recording I'll break the circuit again. Press hold to stop the recording and press MinMax. The maximum was 12 volts, not much of a spike. The minimum was minus 0.4 volts. And the average was 7.8 volts. Did you think that spark was worth only 12 volts? The Fluke 87 has a unique feature, peak MinMax, which is activated with this beeper button. Peak MinMax can catch values that last for just 1 millisecond. To enter peak MinMax, you have to be in MinMax, and we're already there. So I'll press the beeper button, and the meter's recording again. Now I'll break the coil circuit again. Press hold to stop the recording, and press MinMax to view the results. Minus 73.6 volts. There's our spike. Another important use of peak MinMax is to catch a brief glitch in an electrical signal, such as the changing signal from the throttle position sensor while you open the throttle and tap lightly on the sensor to encourage a fault. With the meter recording, you don't even have to watch the display. Let's close with a look at how the relative delta and Hertz functions can help you. Sometimes you need relative information from the meter rather than specific readings. The relative delta function lets you zero the meter, putting whatever reading is present into memory and making it the starting place, ground zero, for all your other measurements until you press relative delta again to leave the function. You may need this when you're checking very low resistances. These days, many antenna systems require very low resistance, both in the antenna itself and in the lead-in cable. In some cases, the spec is less than 0.15 ohms. But the meter's own leads may have more resistance than that. To remove their resistance from the picture, set the dial to ohms and press range to get out of auto range. Auto range works fine for high resistances, but for very low ones, scroll to the lowest range, which is 400 ohms. Then touch the probes together and hold them there. This reading is between 0.2 and 0.3 ohms. That's nearly twice what's allowed in the cable to be checked. So we press relative delta, and the meter accepts that value as the baseline, as 0. Now our measurements would show the resistance of only the cable or antenna being checked. You hold the relative delta button down to leave the function. Finally, let's look at the Hertz function, the frequency counter mode. Sensors like the throttle position sensor send a voltage signal that rises and falls smoothly. Other sensors, including many wheel speed and mass airflow sensors and all Hall effect sensors, produce a pulsed signal. The frequency of these pulses can be measured in cycles per second, or Hertz. With these sensors, like this mass airflow sensor, the control module looks for changes in frequency rather than changes in voltage. To check whether the frequency is changing smoothly, you can set the meter to DC volts, exit from auto range, and select the 40 volt range. Then press the Hertz button. With the engine running and the meter connected at the sensor,